So welcome everyone, and thank you for spending your lunch today with Eos Positioning Systems and our special guests. We're very glad to have you here. If you haven't gotten lunch or a drink, they're in the back. My name is Sarah Albin. I'm the Director of Marketing for Eos, and we have some very exciting things to share with you this year. We're going to have three speakers. To kick us off is Jean-Yves Lauteur. He is the CTO of Eos Positioning Systems. He's actually credited with creating the first Bluetooth GPS receiver that could provide sub-meter and centimeter level accuracy to any iOS, Android, or Windows device. Jean-Yves is going to talk about what's new in GNSS from Eos Positioning Systems. And again, we've got some exciting things this year. After Jean-Yves, we're going to have Eric Gackstatter. Eric is the principal GNSS consultant at Discovery Management Group. He's worked in high-accuracy GNSS for over 30 years. His company deploys thousands of GNSS receivers each year. And Eric is going to talk about the value propositions of the brand new Eos GNSS receivers. And then finally, last but not least, we're having Jeff Shaner speak. Jeff is the Product Engineering Director for Esri ArcGIS Field Maps. With over 29 years of experience building software products at Esri, Jeff is focused on creating mobile solutions that simplify and improve the day-to-day operations of mobile workforces. And Jeff is going to talk about the latest developments in ArcGIS Field Maps. And with that, I'll pass to Jean-Yves.
Thank you, Sarah. Good morning, everyone, and thank you for being here for this presentation. We are going to talk mainly today about the launch of our new GNSS receiver series, the Skadi Series. Is it Skadi? Is it Skadi? Skadi in French for me, Skadi in the US, but in North, where she comes from, it's called Skadi. So if you guys want to be fancy, Skadi. Repeat, everyone. No, don't do that. So, who's Skadi? We'll get back to that after. But right now, let's just say that she builds on Arrow technology, okay, the new receivers, but additional features that add it. And we listen to, over the years, to our customers, see what they want, see what we like, and also what we think that they could use as new features that don't exist yet in the industry, in the market. So that's what the product is all about. And we have four models. Just like the Arrow series, we have four models. We start with a Skadi 100, which is sub-meter. If you go, the one of you familiar with the Arrow 100, and like that's what it is. Single frequency, you get your sub-meter accuracy, and that's the 100. Then we have the lines of RTK receivers, starting with the Skadi 200, 300, and the Gold. And the 200 is a dual frequency receiver. The 300 is a triple band. And the Skadi Gold is the full band receiver. It has everything that moves. So all the signals, so it supports also the Galileo E6, which is still in phase one, but I got news 2 weeks ago from the USPA, European Space Agency, that they are planning really to go to phase 2 next year. So everybody on the planet will be able to enjoy 10 to 20 centimeter accuracy with a reduced convergence time of 5 minutes. So that is coming also next year, so stay tuned for enhancements on the E6, on the Galileo high accuracy service. So this is the lineup of the Skadi series. And to that, we added features. The first one I think that is new in the GIS industry is bringing tilt compensation to the product. So there are hardware features. So also what was needed is to be able to shapeshift in the field quickly. Some people like handheld, some people hate handheld, some people like range pole, some people hate the range pole. So how can we please everybody with a product? That's the challenge of the last 3 years in the making of this product, I can tell you. So I think we came up finally with something good that could be interesting, where you can seamlessly transition from a pole mount, remove from the pole mount, put it in a smart handle, remove your battery pack. You have a hot swap battery in there to keep it alive for 20 minutes, but let's just say 3 minutes, so hurry up. So the backup battery lasts long there. So it keeps it alive while you change. You don't use your RTK, don't use the satellite convergence, put back your handheld, put the battery back underneath it. And this is what the handheld setup would look like. Here I have an iPad, but you shapeshift from pole mount, clip it quickly on the spring-loaded bracket, release your batteries, change it, put it in there, and you have your receiver on the pole, and vice versa. So integrated antenna also inside the receiver, even though you can plug in an external antenna with the product if you require one, because some applications require a vest where you have the receiver on the front pouch, forestry, for example, or natural resources. You want to carry the receiver in your front pouch, have the antenna on the hat or on the shoulder, you can do that still with connecting an external antenna to the Skadi. So, and there are two main features. Again, the one is on the receiver itself on a pole. So that's tilt compensation. We'll talk a little bit about it afterwards. And then the handheld configuration. And every receiver comes with a handle, but we call it the dumb handle. Don't say that too loud. It does nothing, just a handle. It's support for your phone or bracket, and it comes with brackets for phone, the big one, and for iPads and iPad minis, and a small one for phones. Why do we do two brackets? Is because you can rotate easily and free your camera so you can take pictures, do augmented reality while you're holding the receiver in your hand also. So we have two brackets that come. There are standard brackets that you can find on the market. You don't like this one, you can put in your own on the standard universal ball mount. And on the smart handheld, you have two features that we're going to be talking about, also that you can make use in certain conditions. First one is tilt compensation. I think the market needed that. I visited a customer that was doing beta testing for us, and then what he first said, he says, well, this is going to solve a big problem that we have. And I said, which one? So we got a certain guy, whenever they get the data from the field, they know it's this guy. He never wants to level his pole. And I said, yeah, it's always off by 6 inches at least. So we call the guy the 6-inch man. So we know that is his nickname now after I left. They call him the 6-inch man. So he never levels his pole and the data can be off. And this is what the tilt compensation is going to do for you. You just go there, pick up your point, record it, no worry if it's level or not. The accuracy of the IMU inertial sensor is about 0.3 millimeter per degree of tilt. So if you're down 10 degree of your tilt, then you're at 3 millimeter. 100 degree at 3 centimeters. 100 degree, you'll be digging the ground with your receiver. So stay up. So 45 degrees, 60 degree, even there's something underneath the car, you just put your pole there, and it measures always at the tip of the pole. So this is what tilt compensation is. So I can be like this with the receiver, and what is always collected is this. The only important thing, you need to enter a proper antenna height, and whether you're moving this, that point won't change. You can see it in field maps, and there are demos that we do outside. You would move, almost lay it down to the ground. That point never changes. So this is what tilt compensation does for you. And the tilt is available on the 200, Skadi 200. I have to say Skadi 200 because sometimes it can be Arrow 200 and Arrow Gold, so we have the same numbers. So Skadi 200, 300, and Gold, the RTK receiver. Initialization, what you require for tilt is just have a proper antenna height. Very important to get your pole height, I'm sorry, not antenna height, pole height from the bottom to the top, the bottom of the receiver to the bottom of the pole. You enter that. That's very important to get accurate tilt measurements. Second thing you need is the RTK. And after that, once you have those things running, all you need to do is quickly initialize, just a quick shake of the pole, start walking fast, and it initializes the inertial sensor so it detects a movement with GPS. Second set of main features that we have is with the smart handle. When you insert your smart handle, you can activate it for two modes. One of them is called the invisible range pole, which we call. A lot of people have done some RTK in their hands, even we had brackets for the Esri series, and you do RTK in your hand, fine. You want RTK in your hand, but the antenna, there's no way to put an antenna height in field maps for that. So your elevation is always computed at your hand level. So as you move, you go up and go down, you never know what the elevation on the ground is. People say, yeah, but what if I want to stand on a point, I just don't need very accurate horizontal, any precise elevation. Instead of having the height here, can I get it on top of the valve I'm standing on top of it? And this is where we have integrated a LiDAR sensor, along with the inertial sensor of the Skadi. You're now able to get your elevation not on the hand, but on the ground. So think of it, even if I'm like this, think of it as a plumb going down to the ground and always measuring your perpendicular to the ground. So this is one feature. So you can be standing on top of a manhole, hold it there, record your point in field maps, and then what you get is X, Y, Z at the floor. Second mode, say, okay, while we're here, why don't we do a little bit more? So with the press of a trigger, you have a trigger here, you change modes. With the press of a trigger, you can now, with a laser pointer that turns on, aim at assets nearby around you. It's not a laser offset. Think of it as taking this pole and extending your pole to about 20 feet and capture that. So same principle as the tilt, but with an invisible, extensible virtual range pole that you're doing. So, ouch. How is that beneficial to you? Yes, you have objects, you have valves and manholes in the middle of the street, you don't want to go there, just stand, become lazy. You stand and then just aim and you shoot your asset and right away it populates in field maps. You want to do a line, a center line of a road, stay there, aim and zoom. Another thing that is going to be extremely useful for is for as-built, but bury assets that are ready to be buried, like open trenches. People hate going in there, I heard. And then stand on the top. Don't go there anymore. So you have a valid RTK position in your hand. Your laser pointer points here, and you can map your entire line sections or individual points along that structure and map them with vertices, or you can hold the trigger and map them continuously as a line feature, a point every second. So that is a short distance, but it does what it does. It does a lot. So this is the second feature of the smart handle, invisible pole. The second one is the extensible virtual range pole with the laser pointer that comes up. Now, who is Skadi? Go back to that. She's in the Norse mythology. She's known as hunting on skis. You see on the bottom left, you have Heracles. Heracles, which we use on the Arrow product. It shows strength, his foot on a rock, and bow his arc, and then aims right and gets you the accuracy that you want. Skadi is agile. She's on a mission. She has that same precision with her arrow. And she goes down the slopes, the hill slopes, with her skis, hunting and being precise. She's on a mission, she's on a go. And this is what the product is all about. And the product embodies who Skadi is. Getting accurate measurement, doing your job while being on the move, not having to waste time leveling your bubbling again, just collect your point, go on. Okay, I'm on the trench, I want to go down, I want to go there, I want to go down. Take the laser handheld shape shift and the quiver, I call this her arrow quiver. And load on your arrow quiver, take your arrow and shoot. So this is who Skadi is, and this is what embodies really this product. And right now, we developed the product in a way that field maps can consume everything that we're doing on the Skadi without even supporting any special features of Skadi. Field Map will just consume everything that we send. We control everything. There are ongoing work, and we'll talk about this a little bit later, is integrated metadata for the till compensation, for example, inside Field Maps, and some other features that Field Maps could use from the smart handle and other data that could be used. So we're working together, and we'll talk more about this, but in the fall we should start seeing things, hopefully. And quickly, I'll conclude with a roadmap on the Skadi Series ongoing development. Product should normally start shipping late August, early September to mid-September. We're probably going to be doing some slow shipping at the beginning, but there's some development going on also, mostly on the app side. And subscribe to our newsletters to learn more when we start shipping. On the Arrow series is not going away. Arrow series and Skadi series are basically built on the same technology. Some of them has more features than the other. One series has more features than the other, but Arrow still continues. So we're going to have some more development on the Arrow product line, especially for the firmware updates that people have been waiting for. We're finally going to have that. What took us a long time is the release of the new, our next generation Eos Tools Pro, which has completely been rewritten. And that should be released in about a month, at the same time as we start shipping the Skadi products. And 2025, we're looking at probably having the same smart handle, which is a very comfortable grip, for the Arrow receivers also. It's not going to have all the features of the Skadi series, but at least a handheld that will be there. And on the Eos Tools Pro, we're going to have MDM release for Android also. And all this should happen early Q3, end of Q3, I'm sorry. What are we? We're in Q2? Hold on. We're in Q2, right? No, we're in Q3. We're starting Q3, I'm sorry. So yes, so during the Q3, third quarter, we have this. We're going to be adding also the 14 time-dependent datum transformation that solve a lot of issues. So we'll be doing ITRF, WGS, different version of the WGS84, 90D3, supporting 90D3 CS for the California Special Reference Systems with the various epochs that they have. So all these are going to be integrated into the next generation app. They are ready. It's just that we're waiting for the next gen app to be out. So, and Windows in the fall. We're going to have a Windows version that supports the features of Skadi, but I don't know if there's a lot of people using the Windows version of Eos Tools Pro. So with this, I'll pass it on to Eric.
So yeah, I'm Eric Gackstetter. I've been in the GNSS industry for 30 plus years now, and seen a whole, if you've been in this industry for a while, you've seen a lot of different transformations, right? You know, it used to be the old handheld GPS. I've got some pictures of me using handheld GPSs back in 20 years ago, I've mapped a lot of golf courses actually, and it's come a long way. And the major transformation really was the BYOD transformation. So from proprietary data collectors, which I started out with, I was with a company called CMT back in the 90s even, right? Where we had our own, it was a spinoff of Hewlett Packard. We had our own data collector that would RS-232 serial cable to a GNSS receiver, and I'd collect data that way. And there was tons of different proprietary data collectors, because that's, Windows Mobile barely existed. iOS and Android didn't exist at all. And so it was a huge transformation, 12 years ago or so when iOS and Android really started to come on strong as mobile phones. And of course, we started to think about how can we use these as data collectors for GNSS data. And then John Eve came up with the idea of Bluetoothing and came up with the first iOS Bluetooth sub-meter receiver and RTK receiver. And so I'm going to talk about that just a little bit, that whole transformation. And how this is sort of represents in my mind what EOS is introducing as sort of the next phase of BYOD, right? So benefits of BYOD in general. It's in the last 10 years, we went from the mobile device with the GNSS receiver, so integrated, right? So you had a handheld with a proprietary Windows, well, not proprietary, but Windows Mobile operating system, with the GNSS receiver all in one, like the the Trimble Geo 7 series or GeoX series. It was a great machine for a long time. Did a great job. But what happens to those, right? Is that Microsoft stopped supporting that operating system, and then you're stuck. What do you do now? Okay, and so at that point, instead of one handheld package, you started to separate them, right? You separate the data collector from the GNSS receiver, and that's when the whole BYOD, bring your own device concept came around. And of course, the benefits are you expand the useful life, right, of the device, so there's not obsolescence with the operating system. That was a big deal, right? And even we see that now is even more recently when, because when we separated the GNSS receiver years ago and started using Android and iOS devices, manufacturers tried to find certain ways to bring them back together. They would take Android devices and wrap plastic around them and sort of put a antenna on top of that. But that's tough, because when you ship that kind of device and it's all tightly integrated like that, when it goes to try to update the operating system, what happens? You can't, right? So Android changed so much over time. iOS, you couldn't do it at all. And so you'd have a device that you bought that would be obsolete after 2 or 3 years. We saw many cases of that, and maybe some of you suffered from that too. But there's always this argument or debate, I guess, when I talk to field people is, hey, why can't you just make everything in one mobile device, or why can't you even put RTK in your phone, right? Why can't it just be just a simple device, and why do I have to have these add-ons, right? But and I've actually talked to Apple and the Android folks about, hey, why can't you put RTK in the phone? And the answer is interesting. It's the chipsets are more than capable of it, but they don't want to allocate the resource, the power draw, the different kind of antenna that you would need to use to make that work reliably, right? So it's not going to be in the foreseeable future that you'll have centimeter accuracy or even sub-meter accuracy on your phone. In fact, it was interesting, probably 4 or 5 years ago, there was a chipset from Broadcom that was dual frequency, and people started talking about, hey, you're going to get high accuracy in your phone now, because now Android and iOS are going to have these really high-end chipsets. But the reality is it doesn't happen. It's because these folks, the mobile phone manufacturers, really don't care about the high-accuracy market, so they're not going to spend the money. I remember talking to some Samsung folks, and they said, look, if we have to spend 2 more pennies cents on an antenna, we can't afford it, because you multiply it over 50 million phones or something like that. So it's interesting that there's news releases out about new chipsets, GNSS chipsets and so on for high accuracy, but the reality is that the iOS and Samsung folks are never going to implement that. So you're left with having a separate antenna, a separate GNSS receiver, and how do you sort of incorporate into one handheld package? So we did that. So 10, 12 years ago, John Eve and his crew and others said, hey, we're going to use Bluetooth. We're going to have a separate receiver with your iOS or Android device. And it made it work for a long time. And the Aero has been on a great run, the Aero series, for the last 10, 12 years. But it's time for sort of the second generation, the second transformation of sort of the BYOD, right? And it's interesting, because I've been talking about this for a long time at different conferences. It's this whole idea of sensor integration, right? And I was excited when he showed me this, how we've seen sort of this sensor integration start to happen now. It's not just a mobile device, Bluetooth to a GNSS receiver that's getting a position. The whole Eos technical crew has taken that a step further and integrated the tilt part of it. And I'm telling you, if you've collected a lot of data, and you can understand how much time it takes. And I've been on many golf courses where I'm just mapping irrigation heads, and there's, I don't know if you knew it, but there's probably upwards of 2,000 irrigation heads on a golf course. And so you're planning each additional second you don't want to worry about that, right? So when I'd go out and typically map a sprinkler head, I'd walk up to it, bubble up. I'd have to look at the bubble on the range pole, tap the button to store it, make sure I haven't bubbled up, and then you move on. Whereas now with this whole tilt compensation stuff, and it's amazing, you should come by the Eos booth and they'll show it to you. You can just walk up, as long as your range pole is on the asset that you want to map, it doesn't matter if you're level or not, just hit the store button, and it's automatically going to output the data for that point on the ground. instead of where the antenna is. Because I spent years and years telling people, make sure the antenna is where you want to map, because that's what's going to be mapped, right? But that isn't the case anymore. And so that tilt sensor integration is cool, and it's not the first time that someone has done it, but I think EOS has done it in a way that it's very affordable now. You don't see it in any kind of class of receivers that you see that EOS is introducing. So the second, maybe even more cool, in my opinion, that's more innovative, is the whole smart handle capability. And again, you can go down to the EOS booth and have them demonstrate it to you, but you've got a trigger on this handle. It's got a laser pointer. It's not a laser rangefinder in here. It's just a laser green dot pointer that you can see out to about 20 feet. And it's got a LiDAR sensor that does the measurement to that point, right? And you combine that with the tilt compensation, so you're actually getting the position of the asset that you're pointing at. And so, you know, when I talk to a lot of utility field crews about mapping inside trenches, right, and not having to jump down inside the trench, I mean, that's always a big safety thing, and you get unions involved and other things like that. So, yeah, I think it's going to be a big innovation, and it really brings together that whole sensor fusion concept that's been discussed for many, many years. I've been talking about this for 10 years, and so we're finally seeing the IMU come together with the LiDAR sensor and the laser pointer. Yeah, any questions at all along those lines, or anything about trends at all? I mean, still, you know, in terms of GNSS, we're still at, you know, 4 constellations is it. Johnny talked about Galileo. Correction service is going to be improving. We've seen a lot of uses of it, and it's brought some really amazing positioning to areas where you don't have any connectivity at all. Of course, I'm still a big RTK person. We deploy a lot of RTK kind of systems, but what's the Achilles heel of RTK? It's connectivity, right? And so that Galileo correction service allows you to work in crazy parts of the world with no connectivity. Or you can use Starlink. I mean, we're starting to use Starlink now for connectivity too out in these remote locations. So, and I think the last thing I want to discuss on this that I think is cool is the whole idea of you don't have to buy everything at one time. You can just buy a straight up receiver, either on the pole or using the standard handle, and use that out of the gate. And if you want to add tilt later on, you email EOS and say, hey, I want to buy tilt. They activate it over the air, so you don't have to worry about sending a receiver back. So tilt's easily activated, and the smart handle is just a simple accessory. You saw how John Abe, you tap a button, you pull it out, and you install the smart handle to add LiDAR and MEMS capabilities. So that, in my mind, and this isn't the marketing spiel that EOS gives you, but I think the beauty of it is that you can phase in these different technologies over time. You can buy a receiver this year, activate tilt next year, buy a smart handle later on, and activate those features in it. And I think that this adds, from a budgeting standpoint, from a flexibility standpoint, I think it adds a lot of value. And just a couple of examples of how, you know, you could utilize these different technologies, these different sensor technology. And I tell you, you know, I don't do much field mapping anymore, but back when I did, being able to hit, you know, irrigation, it's amazing how many irrigation heads are planted next to tree trunks underneath these big pine trees. And be able to step back and just point a green dot laser at an irrigation head and take a shot would be a big productivity changer. And that really is what it's all about, is making it much more productive tool set than is available today, or has been available today. So with that, I think I'm done, and I'll pass it on to Jeff.
All right, thanks. Thanks, Eric. So as Sarah introduced me earlier, Jeff Shaner, I'm the lead product engineering director for our ArcGIS Field Apps at Esri. And what I wanted to do today was kind of talk to you about ArcGIS Field Maps, where we are today, and overall what our strategy is with field operations at Esri. How many people here are using ArcGIS Field Maps in their day-to-day work? The vast majority of you, great. You know, just to kind of recenter on what our strategy is overall, what we're doing with our mobile products is looking at all industries that we support with ArcGIS and trying to bring the concepts of maps and forms out to the field. for different types of use, whether that be the way that you plan and coordinate between the field and the office to improve overall situational awareness, or whether it be using maps or forms as a container for capturing and updating information that goes back into the GIS. And I'm sure a lot of you here today are using it for that purpose. And our integration with Eos positioning is critical to that success, as I'm sure a lot of you map asset locations that demand that high accuracy GNSS integration. And it's been wonderful to work with Jean-Yves and the team. I'd say of all the vendors that we work with and support today, we're seeing the most growth and rapid adoption of the EOS-based receivers. So it's wonderful to see that happening, and the Skadi being introduced, and that technology evolving once again. So thank you, Jean-Yves. So we look at all of these different patterns of use, and we try to build applications and capabilities that best suit the common needs between each. As you know, data collection is so important. We have 3 applications to support it, and they all are usable with EOS receivers. And we continue to grow each of those applications with new functionality all the time. And with ArcGIS Field Maps, what we've done is we've kind of exemplified those patterns of use, that planning and coordination, that using maps for situational awareness, using maps as a container for data capture. And if you weren't aware, Field Maps as a mobile application supports all user types in the system. And you know that those user types just changed, right? So if you're using a viewer or using a contributor license, you can take maps out into the field and view them. You can view them with high accuracy GNSS receivers. They can work offline. You can get geofences that notify you of information that's nearby. So there's a lot you can do without even editing inside of Field Maps. And what we've done as part of ArcGIS Field Maps, we merged 3 applications together historically. We merged Collector, if you used that in the past, Explorer, and ArcGIS Tracker into one app. And in order to kind of continue to grow the functionality of ArcGIS Field Maps and still keep it simple and easy to use for those that you serve out in the field, we introduced a web application called Field Maps Designer. You can see it here. How many people here have used Field Maps Designer? For those of you that put up your hand and said Field Maps mobile app, but didn't put up Designer, you should feel shame right now. You should feel a lot of shame. Because you're not doing the best for your mobile workforce, right? You can configure that experience so that they make the most out of it. And you get the most out of it too. And we continue to grow the Designer to introduce new functionality into the mobile application as well. And you'll see that in the list of things I have in the what's new over the past kind of 3 to 4 releases. Of course, you're all familiar with the mobile application for those that have used it. And starting with the first release of Field Maps, you can tell we've done a lot more with it, right? Like we've not only continued the integration of GNSS receivers and supplemented some of the data capture functionality for spatial, but also introduced forms. And the way that we did that with forms is that we worked with the other teams at Esri to build a new form specification. That form spec and the components for designing a form that are in this Field Maps Designer app I just talked about are inside the map viewer, inside of ArcGIS Online and Enterprise. Those forms are now executed in that new web editor that just got released, in Experience Builder, and we're taking that to Pro as well, so you don't have to do that dumb attribute editing anymore in future versions. So the next goal for us with those forms is inside of ArcGIS Pro. But we continue to grow and add new functionality around those patterns of using a map to notify people, using a map to capture data, using a map to inform you from the data that's within it, things like support for utility networks, support for linear referencing. We're going to bring more support in for rasters here in the next little bit. So there's a lot of functionality that continues to grow inside of the mobile application as well. But what's really important is for data capture is this integration with GNSS receivers. And like I mentioned, the Eos units, the new Skadi, this revolution in technology that Eric was talking about over the years is really important to the work you do. So we want to make that as seamless and easy as possible. So what we do today is we're leveraging the Bluetooth connection, if you know this from using perhaps an Aero receiver, and we pull all of the information off that Bluetooth stream. We can leverage it inside of the data capture today. But what Eos has done is taken that even further. So with the Eos Tools Pro application, you can extend the data capture capabilities of field maps, because we support very basic things like maybe GPS averaging or simple vertex capture, but with the offsetting capabilities that they've introduced and with the line locating capabilities, you can do so much more. Is anyone using the Eos locate capability or the offsetting capability that's here today? Okay, well, if you're not, you should go check that out. And we're continuing to work really closely with Jean-Yves on how we're going to take advantage of the new features that Skadi's providing, and especially with the trigger capabilities moving forwards and the tilt capabilities and all of that. All right. As far as what's new, ArcGIS Field Maps was born in November 2020. It was a COVID baby, and we've had a lot of releases since. We release 3 times a year, and we do that because we're hitched to the ArcGIS Online updates. The source code for the Field Maps Designer is inside of ArcGIS Online's code base. And then that code base gets refactored into future versions of ArcGIS Enterprise, and it kind of goes along like that. So we always release major updates 3 times a year. And you can see a lot of change. I'm not going to go through this full list. Obviously, I'll point out in June of last year, before this conference last year, we added some new functionality to really help promote the accurate capture of spatial data. And that includes bringing into those requirements for accuracy, the fixed type, and also the ability for you to remove a user from being able to capture with a map. So if you want to force someone to use GPS, you can do that inside of Field Maps now. And then we've been spending a lot of time adding more functionality to improve things like offline workflows inside of the product. And you can see a lot of that rippling through each of those release versions. We do have another update coming in October, November-ish. We're really laying out the date now. Again, more focused on Field Maps Designer with some very modest capabilities. One of the things we did quite recently inside of Field Maps Designer is let you create new maps from scratch. So you don't have to go use ArcGIS Pro necessarily to create a map anymore. You can create a map in that Designer app, design the form if you'd like, create your feature layers. And in fact, we even added the ability for you to create a new feature layer in a local projection too, something you can't do outside of ArcGIS Pro anywhere else. We're going to start to introduce templates this fall. Things like simple map notes, or perhaps a template map for creating points for drone flights, control points for drone flights, stuff like that. So we're working with the solutions team to deeply integrate some of the solutions as well. So see this kind of quick ability to create maps and lower the bar of entry for using field maps within your organization. So you don't have to necessarily be a GIS professional to get the maps out to the field anymore. Not much on the mobile front, because right now we're actually in a rebuild of field maps. We've been in that process for almost a year now. And in Q1 of next year, we're going to release a brand new version of it. In fact, we've got early updates of it happening now, and there's a bunch of new features that are coming. Has anyone used ArcGIS Workforce before to organize their work? So we're introducing the concepts of ArcGIS Workforce into field maps, and we're calling them field tasks. So you'll be able to organize the work that someone does in the field. Like, I wouldn't want to send Matt Davis out to go capture a bunch of data on his own. I'd want to give him a list to do so that I know I can go back and look at what did he actually do and track his work. That's a major new development for us, and probably a year or so following that release, we'll deprecate Workforce. So you can know that we're not going to continue to develop Workforce. New functionalities going into the task coordination capabilities. We've been supporting utility networks for some time. Important is being able to take them offline and view and trace. We're overhauling our personal markup experience, really working with the stylus. We'll eventually bring that into data capture of the map too, so you'll be able to freehand sketch in the map. Being able to support the Edit Multiple tool with forms, finally, a big request from a lot of customers. On the location side, one of the things that we've struggled with is we've had multiple location providers inside of the application. And that means that if you're using geofencing or location sharing, it couldn't take advantage of the Skadi, for example. It was using the integrated location coming from your iOS or Android device. Now that is fused together. So we've got a lot of new developments coming there, and look for that to be released in Q1 of next year. Obviously, utility network is coming. And if you want to talk to us at the Esri booth, you can come down into the expo. And also Jean-Yves, we've got the Eos Positioning booth that's really close by to the Esri booth. We want you all to come down and interact with the Skadi. And then I think that's it. And if there's any questions or if you want to contact Eos, I'll put that slide back up. You can see the QR codes here.
Thank you, everyone.